Hello guys, welcome back. So here we have another question on communication systems from GATE EC 2021. Consider a carrier signal which is amplitude modulated by a single tone sinusoidal message signal with a modulation index of 50%. If the carrier and one of the sidebands are suppressed in the modulated signal, the percentage of power saved rounded off to 1 decimal place is dash. So what they are saying, we have an amplitude modulated signal. So the carrier signal AC, let's say cos omega ct. This is our carrier signal. So it is getting modulated by a single tone sinusoidal message signal. So what is a single tone sinusoidal message signal? So it is having only one frequency. So let us for now assume it is AM cos omega mt, and this is your message signal. And now your carrier amplitude is getting modulated with this. So what will be your modulated signal? Let me call it S of t. So this is AC plus AM cos omega mt into cos omega ct. Right? Now they have given the modulation index is 50%. So for this, what is your modulation index mu? Mu is nothing but AM by AC. So this they have given us 50%. So it is equal to 0.5 or 1 by 2. So now if you write out this signal S of t, so it has one component at cos omega ct. So this is your carrier itself. Other than that, you have another component which is cos omega mt into cos omega ct. So this one you can write it as half of cos of omega c minus omega m into t plus cos of omega c plus omega m into t, right? So then actually you have three components. So AC cos omega ct plus half am cos of omega c minus omega m into t plus half am cos of omega c plus omega m into t. So in the frequency domain, if you were to plot, you will have one carrier and two sidebands. So this is omega c, this is omega c minus omega m, and this is omega c plus omega m. And depending on your modulation index, the height of these will be changing. So if we are to write in terms of power, what will be this power? So this power is, always your cos or sine omega ct whole square. The power of this is equal to half. So what will be this power? This will be AC square by 2, and this will be 1 by 4 am square by 2, and this is again 1 by 4 am square by 2. So that same we can write here. This is am square by 8, and this is also am square by 8. So now you also know that your am is nothing but it is AC by 2, right? We got from here. So what will this correspond to? This is AC square by 2. So this will be am square by AC square by 8 into 2 square, which is 4. So it is 32. And this is again am square by 32. So what is the total power saving you get by suppressing these two bands? Let's say these two are not there. What is the total power saving? Or we want in terms of percentage, right? So percentage power saved is equal to how much we are saving? We are saving am square by 32. Oh, this is AC, right? So this AC square by 32 plus AC square by 2 on top of the total power. Total power is AC square by 32 plus AC square by 2 plus AC square by 32. So this is equal to AC square we can cancel, and percentage you can put as 100%. So this is 1 by 32 plus 1 by 2 divided by 2 by 32 plus 1 by 2 into 100%. So 2 if you knock it out, you have 16 plus 1 divided by 1 by 8 plus 1 into 100%. So this is nothing but 17 by 16 divided by 9 by 8 into 100%. So this is nothing but 17 by 18 into 100%. So for this you can use calculator, and 17 by 18 turns out to be 0.944. So in terms of percent, it is 94.44 percentage. So this is the percentage of power saved. So they're asking us to round to one decimal place, so it is 94.4. So one mistake which can happen here is you may ignore this factor. So in which case you will directly, if you try to apply the formula by saying that you remember it very well, you may be doing it like 1 square plus mu square by 1 plus 2 mu square, right? But if you actually see, the power of the message signal is not mu square but mu square by 4, and there is another factor of 2 coming because of this cos, right? So if you normalize this with respect to 1, this will be mu square by 4, and this will also be 2 mu square by 4. So you should be careful while doing directly applying the formula, okay?